Hello and welcome back. Today we're going to be looking at the binomial theorem. So this is kind of an interesting way of tying everything with Pascal's triangle and Pascal's triangle combination form together with our expansion of x plus n or x plus y to the power of n. So if we just looked at right here x plus y to the power of 6, that is the same thing as x plus y, x plus y, x plus y, x plus y, x plus y times x plus y. Now, let's say I wanted only the first term of it. So right here, this is x to the power. We want 6 x's and 0 y's. So I'm looking at this, I'm choosing 0 y's. So out of a possible of 6 of these y's, terms with y, we're choosing 0 of these multiplications. And we want then what's left is we take all 6 of the 6 x's. So that's why it's 6 choose 0 multiplied, you might say, by 6 choose 6. Now, if we look at the second term, if I say I only want the second term is only 1y. So out of a possibility of 6 y's here to choose from, we're choosing one of them. So out of 6, we choose 1 y, and then we're left with the 5 x's out of 5 to choose from. Okay? Now we look at the last one, the next one here. If I want to find this one here, which is 6 choose 2, that's saying out of each term, out of each of these, we're choosing 2 of them, like let's say those 2, and those are going to be the y's used, and then out of the rest we have 4 out of 4, 4 choose 4. So that's like 6 choose 2 times 4 choose 4, which gives us those. So we'll get a little bit more into this to help you understand. So let's look at this here. We want to write these in terms of combination. So my first one is we want x to the power of 6. What is that in terms of combination? So here, out of 6 y's, we are choosing, or 0 of them. We want a combination of 0 of them, and that will give me x to the power of 6. That's how I find my coefficient of that one. Now, the next one is out of 6 y's, we are only choosing 1. So 6, we are choosing 1, and then we have 5x, so 5 choose 5 combination 5 x's, and we have y1. Okay, so the next one here, we're choosing 2. Okay, then I go on. So now we want to choose 3 out of the 3 y's. So out of 6, we're choosing 3 y's, and then we take the 3 out of the 3 x's left over. So that's going to be, we could write that in, 3 choose 3, but then we have x to the power of 3, y to the power of 3. Then the last one here is we want 4, so the 6 y's, we want a combination of 4 of them, and we're left with x squared, so that's out of the 2 x's remaining, we choose all 2, so 2 combination 2 is always 1, and we have y to the power of 4, plus, now here we want 5 y's, so out of 6 y's, we want a combination of 5 of them, and then there's only going to be one x term left over, so out of x we just take the one x, and that's going to be x, y to the 5, and then for the last one it's going to be plus 6, and we are choosing 6, and a combination 6, y to the power of 6. Even if we did it looking at x's first, we would get the same answers, because we would say out of 6 we're choosing 6 x's, which gives me 1, right? So we could go 6 combination of 6, that means there's no y's to choose from. Then we could go 6 combination 5, which is there's no 1 y to choose, 1 y, so 1 out of 1. And we could work in reverse, but it doesn't matter how we look at it, but the same idea is happening there. Okay, so eventually, we get something that looks like this for the binomial expansion. Okay, so x to the power of n is equal to whatever my n is, my exponent is, and we're going to choose 0, x to the n, and then we end up going n, choose 1, n minus 1, x, and then we have a y, which has a 1. Then we have a 2 there. So if we look at this, this is always related to, continuing here, we have this 0 is related to my y power of 0 because there's 0 y's. This 1 is related to my y power of 1. This 2 is related to my y power of 2. And 6 is always my n value. So that 6 stays there. And what we're doing in combinations of is related to the powers of y. And it's starting from 0 going all the way up to n, which is my power. Okay? So that is eventually we end up getting this formula here. So this is my term. So going back here, we look at this. We have term 1 is when we have k value, is when we're 0. Term 2 is when it's 1. Term 3 is when it's 2. So we're always, the term is always 1 greater than my combination I'm taking of. Okay? So that's how we get this equation here. So my term is always 1 greater than going here. And I'll explain this here with this question. So here we want the fifth term of that there. So we want the fifth term. So we want T5. So if I look at the fifth term, so even if we look back here on the fifth term, 1, 2, 3, 4, 5, it's only the fourth one there. And so my y value is only going to be to the power of 4 on the fifth term since we're starting at 0. So my k value here is going to be 4. Okay? My n value is going to be, we want 8. My n value is equal to 8. Okay? So we want to figure out what is the fifth term. It is going to be, we have 8 combination of 4. So I'm going to go T5 is equal to 8 combination of 4. And then we want x to the power of 8, subtract 4, y to the power of 4. So 8 combination 4, I could put that into my calculator here. Just quickly go. We're going to go 8 math, and we're going to go all over. Combination of 4 is going to give me a total of 70. So this is going to give me 70 x to the power of 4, y to the power of 4. So that is going to be my fifth term. Now it wants to find the middle term of this. Okay? So my middle term, if I look at this, there's actually going to be 11 terms. Because there's always one more. Because we go from 0, from my y's, 0, power of 0, all the way to 10. So there's 11 terms. So my middle term is actually going to be the sixth term. So we want T6 is equal to something. Well, that means my k value is going to be equal to 5, because it's got to be 1 less, right? And then my n value is equal to 10. So we have this, we're going to have 10 combination 5, and we're going to get a to the 10 subtract 5, and then b to the 5, which gives me a total of, we could put in 10 combination, so we're going to put that in here, 10, math, go over, 5, and then we have 252, so that's going to give me 252, a to the 5, b to the 5. Okay? Now it says use the binomial theorem to write the expansion of this here. So we want to use the binomial theorem to write that in expansion form. So we want we're going to have here x plus y to the power of 7 is equal to, we're going to have, we're on the 7th, so that's going to be out of 7. We're going to choose 0, combination 0, and I'm going to have x to the 7 plus out of 7, combination 1. And remember, this is my y value, so it's going to be x to the 7 minus 1, which is 6, and y to the 1 plus 7 combination 2, which is x to the 7 minus 2, which is 5, and then y to the 2 plus 7 combination 3, which is going to give me x to the 4, y to the 3. And remember, my exponents must always add up to my power. Okay, so they are always adding up to 7, so it kind of follows the rule as well. Plus, and we're going to have 7 combination 4, which is x to the power of 5, x to the power of 3, y to the power of 4. And we have 7, 5, which is x squared, y, because 7 minus 5 is 2, y to the 5. And then we're going to have 7 combination 6, which is x to the power of 1 and y to the 6, and then we're going to have plus 7 combination 7. Oops, sorry, ran out of room there. 7 combination 7, and that's going to be y to the 7. Okay, so we're going to continue this here, and I'm going to end up getting x to the power of 7 plus 7x to the 6 y plus, next is going to be 21, x to the power of 5 y squared plus, next is going to be 35, x to the power of 4 y to the 3 is going to be plus 35 x to the 3 y squared plus, we're going to have 21 x to the, oops, y to the 4, x squared y to the power of 5. Notice how this is the same as that, they're just reversed, plus 7 x y to the 6 plus, then we're going to have y to the 7. So that's all it is. Okay? So now classroom example number 3 says, Susan was determining the fourth term of the following here. So 2x minus 5 to the power of 6. Part of her work is shown below. Complete her work and show the fourth term is negative 20,000 x cubed. So right here she has the fourth term is equal to this. Let's see if she's right. So we have x is equal to 2x. So we put that in. Okay. So now we continue this. This is going to give me 6 combination 3 is the same as 20. And then we have 2x to the power of 3 minus 5 to the power of 3. So that's going to be 20 times 8, which is going to give me 1600. So that's 160, or 20 times 8 is 160 x cubed minus 125, and we multiply 125 by 160, it was going to end up getting me negative 2,000 or 20,000 x to the power of 3. Okay? So we get the same answer. Alright, so now let's take a look at class example number 4. It says, determine the fifth term of the following. So the fifth term, we are going to write this out here. So we know that T5, so then we have K is equal to 4, because it's always 1 less than that. And then we have here Y is equal to, Y is going to go to 2Y, and it's negative, because it should be x plus y to the 7. And then we have x goes to 3x, and my n is equal to 7. So let's plug this in here. I am going to end up going with my formula. We have T5 is equal to, we have for n it's going to be 7, and combination, and 4. Now for x, we have to put in 3x, so it's going to be 3x, all to the power of, and we have 7 minus 4. And then for y, we're putting in negative 2y, all to the power of 4. Okay? So we continue this. 7 combination 4 is the same as 35. And we have 3x, all to the power of 3, minus, and we have negative 2y, all to the power of 4. Okay? So this is going to end up giving me 35 multiplied by 27x cubed multiplied by, and that's going to be 16 y to the power of 4. Alright? Now I continue multiplying this out. I'm going to end up getting 15,120 x cubed y to the power of 4 is going to be my final answer. So now we're going to look at applying the binomial theorem where k is unknown. Okay? So right here, we don't know which term is equal to this, but we could kind of help us find that, okay? Now, right here, we want this part here, and it says we're looking, since the term we're looking for contains x to the power of 4, we can determine that k satisfies this constant condition. So we won't know it's x to the power of 4, but remember, we're replacing x with x squared if we relieve this, because we have x squared there. So that's why when we put this in, we end up getting that there. So I know 16 minus 2k is actually equal to 4. Okay? So now we could just solve for this here. So I end up getting 12 is equal to 2k. K is equal to 6. So we're actually trying to figure out when k is 6. Now, that means we're actually trying to find the 7th term. So we're trying to find when t is 7. Okay? So we're going to put this in. We have t7 is equal to, we have 8 combination, and we're going to go one less because my k value is now equal to 6. So it's going to be 6. And we have here, let's put in, we had x, because we're following this here, x to the power of 16 minus 2k. And in that case, it's 2 times 6. And then we're going to have a to the 6. Okay? So if I continue that, I'm going to end up getting 8 combination 6 is 28. And we're going to have x to the power of, this is 2 times 6, which is 12. So x to the power of 4, a to the power of 6 is my answer. Okay, now it says equate tk plus 1 when I have this and solve for a. So now we want to figure out which term makes that, and we're going to solve for my a value. So here I'm going to have 28 x to the power of 4, a to the 6 is equal to 114,688 x to the power of 4. Okay? So looking at this here, we could, if we know this term is equal to that, we're going to now start solving for a value to find out exactly what it is, because it'll have a numerical value. And we divide both sides by 28 x to the power of 4. So my x's cancel off, and I'm going to be left with a to the 6 is equal to 4,096. So now I want to take the 6th root of this, so I'm just going to go 4,000 to the power of 1 divided by 6, and that's going to give me 4. So I know here a must be equal to 4, and we know that a must be greater than 0, so then this works. Okay? Okay, so let's look at this question here. This will be our last one. So looking at this here, let's just figure out what we know. We want to know what is determine the numerical coefficient of the term containing a to the 7. So first of all, I know x goes to 3, y goes to negative a, and we want a to the 7. We know n is equal to 10. So then a to the 7 is going to be, well, that means my k value, because if this is a, this is my y, and my k value is 7. K is equal to 7. And my term is the 8th term. Okay? Because if we plug this all in, we have t, k plus 1 is equal to, we have n combination k, x to the k minus, or sorry, x to the n minus k, a to the k. Okay? But now we have, or y to the k. So we have 10, 7, x to the 10 minus 3, or minus 7. And then here we're going to have negative a all to the 7. I combine this here, and this is going to give me a total of 120. And we put in 3 for that. And that's going to be 3 to the power of 3. And we're going to have minus 1 to the power of 7, because I'm going to factor out a 1 here, negative 1, and we have a to the power of 7. So we have a by itself. So now we get 27 multiplied by 120 gives me 3,240, and we have multiplied by negative 1, so it's negative 3,240 is a to the 7. So my coefficient is negative 3,240 is my coefficient term for that.